logic gate. It is a circuit which is built using electronic switches like transistors. It takes one or more, at least one, or it can take more inputs and to produce a single output. All the gates produce only single output, but they take one or more inputs. It is building block for almost all the digital circuits. You can't imagine a circuit without these gates. Logic gates operate on two voltage levels representing low 0 and high 1. So it has only two levels. It follows all the rules of Boolean algebra. A truth table is a table which lists all the input combinations for the gate and the corresponding output for each combination. Means it will list all the working of the gate by listing all the input possibles and corresponding output. So we will see all the gates one by one. First of all is the buffer gate. What is buffer gate? It is simply a gate which accept only one input. It can't take two inputs. It will accept only one input. The output is same as input. It does not change the input value, so it simply amplifies the signal. So without changing its logic state, it don't change the signal, it will just amplify it. Its symbol is as given below. This is a gate. The input is X and output is Y. Y is equal to X. There is no change in the value. Truth table for this gate can be shown as below. Here the values of X can be 0. If we give 0, we will get output as 0. There will not be any change. If we give input as 1, we will get output as 1. So there won't be any change. So this is the simplest gate, which is called buffer gate. It is used simply to amplify the signal without changing the signal. Second is the NOT gate. So it takes one input just like the buffer gate, but the output in this is complemented, or you can say inverse of the input. It complement it, means it makes 0 to 1 or 1 to 0, just complement. It is also called inverter gate or inverting buffer. So we use these names, and its symbol is like this. We had this dot in front of the buffer gate. So if input is X, output will be X dash, or you can say X bar. You can also put it like this. So this is the symbol for it. And truth table, you will see if we give the value X as 0, we will get the value as 1. So 1 will be output. If we give value 1, 0 will be output. So this is the NOT gate. Next gate is AND gate, which is very important gate, and it is used for multiplication of two or more binary numbers. So it takes two inputs, two or more, and produce single output. So output will be high if all the inputs are high, and it will be low if any of the input is low. Even if single input is 0, the output will be 0. For getting 1, you must have all the inputs as high, means 1. Its symbol is like this, and two inputs are shown here, X and Y. You will get output as multiplication of X and Y. If we want to see the truth table, you can give values to X and Y as 4 possible values are there: 0, 0, 0, 1, 1, 0 and 1, 1. So you will get 1 only when both the X is 1 and Y is 1. You will get 1 as output, means here you will get 1. Otherwise, if any X is 0 or Y is 0, you will get, if both are 0, 0, 0, 1, 0, 1, 0, 0. So only the high output will be obtained if both X and Y are high, both are 1. Next important gate is OR logic gate. So it is just like the you can say it takes two inputs like the AND gate and produce only single output. So its output will be high if any of the input is high. Even a single input is high, the output will be high, means 1. and it will be 0 if all the inputs are 0 or low. So its symbol is like this: x and y are inputs and you are getting x plus y as output, and truth table which lists all the combination of inputs as 0 0 0 1 1 0 and 1 1. So its output will be 0 if both the inputs are 0. Otherwise, if any of the input is 1, the output will be 1. 1 0 1. Here both are 1, so output will be 1. So output will be low if both the inputs are low. So these are all the basic gates. Thank you.